A practice jump. After some not so high practice dives by the circus owner, the circus performers decide to do a practice run of the show with the diver himself. But they decide to set it up so that they will not have to worry about a moving cart. Instead, the cart containing the tub of water is placed directly under the Ferris wheel's 11 o'clock position. As usual, the platform passes the 3 o'clock position at t equals 0. 1. How many seconds will it take for the platform to reach the 11 o'clock position? Let's remember what's going on here, right? So we've got our Ferris wheel. It always starts at the 3 o'clock position. We're being asked about the 11 o'clock position. And then right underneath the 11 o'clock position, we've got our cart of water. Looks pretty good, right? And of course, oh, there's maybe our center, and then we can just show that our Ferris wheel is standing on a stick. Our first question says, how many seconds will it take for the platform to reach the 11 o'clock position? Here's some things we know about our platform is we know that our center height is 65 feet, our radius is 50 feet, our period is 40 seconds, and I think that's all I need to know. So then we can say the height as a function of time is equal to 65 feet plus 50 times the sine of 360 over 40 times time, right? And this is the height on the Ferris wheel anytime after it passes the 3 o'clock position. We know this. This is review right here. But we're going to actually use this to answer this, or to look into this stuff. Let's see. What else do we know? We know it just said that the... Oh, they decide... Did it say what the height of the water was, or am I thinking of a different one? Okay, maybe we can ignore this for now. How many seconds will it take for the platform to reach the 11 o'clock position? Well, let's think about that. So here, basically the question is, if we know the angular speed, all we need to know is the number of degrees in that angle. Well, we know between each hour of the clock is 30 degrees. And this is 4 hours, right? Your 2 o'clock, 1 o'clock, midnight, 11. So that's 30, 60, 90, 120. So 120 degrees. How long will it take for the Ferris wheel to turn 120 degrees? Well, we know the Ferris wheel moves at a speed of 360 degrees every 40 seconds. So some amount of seconds times that speed is going to equal 120. So what we're going to do is we're going to solve for it. So we're going to multiply both sides by 40. These 40s are going to cancel each other out. 40 times 120 equals 360t. We can divide both sides by 360. Those 360s cancel out, and we end up getting t is equal to 40 times 120 divided by 360. 13 1/3 seconds. .333 seconds. So that's our answer to this first question. 13.3. What is the diver's height off of the ground when he is at the 11 o'clock position? Okay, let me label this, I guess. That was question number 1. Let's do question number 2. Well, the height off the ground, that's just going to be this equation where this is our time, right? So the height at 13.3 repeated seconds is equal to 65 plus 50 times the sine of 360 over 40 times 13.33 repeated, and that'll give us the height. So let's calculate that. Clear all. 65 plus 50 times the sine, oops, I messed it up. 50 times the sine of 360 over 40 times 13.3. Okay, great. So 108.3, it looks like. Ooh, excuse me. Okay, great. Let's keep moving. I guess I can write that right here. 108.3 feet. One purpose of this practice run is to find how long it will take for the diver to fall into the water. You should be able to predict this based on the formula that an object falling freely from rest takes h, the square root of h over 16 seconds to fall h feet. Assume the diver is falling freely from rest. Now, this is one we came up in our last, in the last video, free fall. So if you haven't watched that one, check that out and you'll understand where this came from. 3, how long will it take from the time the diver is released until he hits the water? Don't forget that the water level in the car is 8 feet above the ground. Ah, okay, so it did matter. This distance is 8 feet. Okay, well, how long will that take? Remember, here's what we know. We know that the time it takes to fall some distance, or some height, why don't we call this height, h, is equal to the square root of, the time that it takes to fall that distance is equal to the square root of the height over 16. So time is equal to the square root of height over 16. There's a couple things that we have to remember. Remember, so we're jumping off of our Ferris wheel, and we only care from this platform to the surface of the water. So we're going to have to take away 8 feet from this total distance that we just calculated. Because that, right, is going to be our 8 feet right there. So then when we figure out the time of falling, we'd say, well, okay, great. That just means that the time falling is going to be equal to the square root of 108.3 minus 8 feet, and all of that is divided by 16. Okay. Well, 108.3 minus 8 is just 100.3. Divide by 16. We get out our calculator, and we say the square root of 100.3 divided by 16, and make sure that's in the square root, is 2.5 seconds. Wow, what a cool stunt. That's our answer for number 3. Okay, now, number 4. This one is the bread and butter. This is where everything comes together. More generally, suppose the assistant lets go W seconds after the Ferris wheel starts turning. Here, W stands for wheel time. W stands for wheel time. Assuming the cart is in the right place, how long will the diver be in the air before he hits the water? Well, okay, we know that we just got our answer for how long, right? That this is how long the diver will be in the air. So what I want to do is start here and work backwards to see if we can generalize what's going on. So we know that our fall time is equal to the square root of 100.3 over 16. But remember, we're trying to put this in terms in a term of W seconds of wheel time, meaning we have to go all the way back to where we plugged in this 13.333333 because that is the wheel time. Okay. So well, okay, here we know we get our 16 because it has to do with the Earth's gravity, and the square root because we're solving our distance from free fall equation for time. So we know that the square root's going to stay, and we know that the divide by 16 is going to stay. I'm going to make this a little bit long. Divide by 16. The question is, well, where did we get the 100.3? Well, that was just the height of the Ferris wheel minus 8. Okay, let's actually want to write that. So that's just 108.3 minus 8. Okay. So we're just expanding. And it looks like the 8 is just the surface of the height of the surface of the water. So we're going to keep that in there because it seems like that's where we'll always put the surface of the water. But where did 108.3 come from? Well, that came from this equation right here. And now in this equation, isn't this our wheel time? So what we can actually do, oh, and you all are going to be so impressed by this, is that we can actually just write this number in terms of this function, but now replace the 13.3 with a w for our wheel time. So 65 plus 50 times the sine of 360 over 40 times the wheel time minus those 8 feet. Oh, look, I barely squeezed it in. And all that is divided by 16. And of course, remember the 16 is from the gravity on Earth, or it's the acceleration divided by 2 on Earth. So if you're ever on the moon, you just divide the moon's gravity by 2. But this is our answer, right? Our fall time as a function of our wheel time is equal to this. And let's say we want to generalize it even a little bit more. So we might say our, for like any Ferris wheel, right? So, and why don't we write F for like fall time? The fall time as a function of the wheel time is just going to be equal to the height of the diver on the Ferris wheel, which is just your center height of the Ferris wheel, plus the radius times the sine of 360 over your period times your wheel time minus your, let's call it S for the surface of the water. This is not a 5, it's an S. The S for the surface of the water. All that is divided by 16, and it's inside the square root. And then don't forget, your 16 is equal to your acceleration divided by 2. That's it. If you can understand this generalization of this work we've just done, you're doing great. Okay, and I think that's all there is. Thanks for watching.